Can you reverse a fan motor?
Sometimes, but the safe answer is never. Swap these two wires. Before anyone opens a terminal box, 3 questions must be answered. What motor and controller are installed? From which end is rotation defined? And was the fan assembly designed for that direction? Miss any one of them and a motor that turns can still produce weak airflow, overload the drive, or create a mechanical hazard. Start with the viewing reference. Clockwise and counterclockwise describe what an observer sees from a named end of the shaft.
Look from the opposite end and the same rotor appears to turn the other way.
The paired cross-flow impeller drawings here are both 640 mm wheels, yet one specifies CW and the other CCW from the steel shaft end.
That small note prevents a very expensive misunderstanding. Next, identify the complete system, not just the motor shell.
Record the fan model, motor model, voltage, phase, frequency, controller or drive, connection diagram, rotation arrow, and airflow arrow.
Photograph the existing labels before work.
If the nameplate is unreadable, the diagram is missing, or the controller identity is uncertain, stop.
Guessing from wire color or a generic internet diagram is not identification.
For a 3-phase induction motor, the rotating magnetic field follows the incoming phase sequence, so direction is phase sequence dependent.
That principle does not authorize an improvised change. A qualified person still has to use the exact motor, starter or drive documentation and check interlocks, overload protection, braking, bypass circuits, and the driven fan.
A drive-controlled motor may use a documented direction command rather than any field rewiring. A single-phase capacitor motor is a different machine.
Its direction is set by the relationship between the main winding and the auxiliary winding.
Reversing only the supply conductors normally changes neither relationship nor direction. Some models expose leads that permit reversal according to their own diagram, others are factory fixed. Lead count, thermal protector, capacitor arrangement, and color code vary, so the exact model diagram is the only valid map. EC, BLDC, and electronically commutated fan motors form a third branch. Their electronics create the rotating field. Direction may be fixed by the product, selected when ordering, or configured through a documented input, parameter, or communication command. Reversing supply polarity is not a universal technique and can damage electronics. If the manual does not explicitly describe a direction function, treat the unit as non-field reversible. Even when a motor can rotate either way, the fan may not. Blade lean, inlet ring, scroll, guide vanes, cutoff geometry, and diffuser are designed as a system. The real crossflow wheels on screen show why, viewed end-on, their blade curvature is directional. Turning the wrong geometry backward may move some air, but pressure, efficiency, noise, and motor load can all move far away from the selected operating point.
Mechanical details can also be directional.
A shaft nut, taper lock arrangement, cooling fan, seal, bearing thrust path, brake, or lubrication feature may depend on the approved rotation.
Reverse operation can loosen a fastener, reduce motor cooling, change axial load, or drive debris toward a guard. The decision is therefore, is the entire assembly approved for this direction? Not merely will the shaft spin?
Build a rotation plan before touching the equipment. Mark the required airflow path, the approved observer end, the present rotation, and the desired rotation on one sketch. Attach the manufacturer diagrams for the motor and controller. Then record what will prove success: correct rotation, correct airflow direction, stable current in every phase where applicable, normal speed, acceptable vibration and noise, and no rubbing or overheating.
Electrical work begins in a de-energized state.
Authorized personnel shut down, isolate every energy source, apply lockout and tagout, release stored energy, and verify absence of voltage with suitable test equipment. Use the required protective equipment and local procedure. Never infer safety from a stopped shaft or a dark indicator. If conductors, terminals, or documentation do not match the controlled drawing, stop and escalate to a qualified electrician. After the documented change, reinstall terminal box covers, guards, inlet screens, and access panels before any rotation check. Clear tools and people from the fan path. A qualified person performs a controlled momentary test from a safe position, then isolates again before inspection. Compare the observed rotation from the specified end with the arrow, and confirm airflow, phase currents when relevant, drive status, noise, vibration, and mechanical clearance.
So the practical answer is a decision tree. 3-phase, verify the documented phase sequence or drive control method. Single phase, follow the exact winding diagram, or do not reverse it. EC or BLDC, use only the manufacturer's supported control path. In every case, validate the fan geometry and the whole assembly, not just the motor. The best reversal job is not the one that merely turns, it is the one whose direction, airflow, load, guarding, and evidence all agree.